No problem.
So guys, let me introduce Paul formally first of all. So Paul, he's the principal automation architect at Magenic. He holds a master's degree in computer science, and he's also a Scrum Master, a certified Scrum Master from the Scrum Master Alliance, if I remember correctly. His field of expertise is on building automation platforms and tool frameworks that have been used in many, many environments and a whole range of different industries. If you are around testing, then you should be familiar with Paul, because he's actually someone who's he's around very much, and you can hear him and read the stuff that he's doing. He's a very experienced speaker. He's also an advisor for the software testing professional STPConf. And something that I didn't know, he's an industry advisor for the Advanced Research Center for Software Testing and Quality Assurance at UT Dallas. Now, Paul, you're going to be talking about automation. I mean, not your parents' automation, right?
Yes, I am.
So I guess that you can share your screen, and we can take it from there. Oh, by the way, last thing, guys, remember, questions, use the Slack, use the Q&A, and we will be asking Paul all sorts of questions once we're done. Okay, so Paul, I leave you, floor is yours.
All right, thank you very much, and thank you for spending your time with me today, everyone. As Joel said, my name is Paul Grizzaffi. I'm going to spare you the rest of this stuff since he just gave me a far better introduction than I can do for myself. Here is some contact info for me there, but you don't have to scramble to write that down now. I will have it up on the Q&A slide at the end if you're interested in contacting me outside of this forum. And then that bottom one there is my blog. So I'm not a big agenda kind of guy. I'm more of a jump right in kind of guy. So when I say automation, what comes to mind? What are the things that you think of? And when I talk to people at conferences and meetups and on the internet and stuff, general themes and topics tend to come up. And one of the first things that almost always comes up are scripts. And it's, hey, how many scripts do you have, and what kind of scripts did you write? And those scripts, as we know, they almost always come from test cases. So we have our test cases and we write scripts so that they're automated. And of course, we need a tool or more than one tool to be able to build these scripts to automate these test cases. And everyone knows that the big prize, right, is the automation of regression testing, because that's where we spend all this large amount of our time, is going through these hundreds or thousands or multiple thousands of test cases, quote, by hand. So that's going to save us a lot of time once we've automated all these test cases using tools and scripts for regression testing. But wait a minute. What do we do with all that saved time? Are they going to lay me off? We don't need testers anymore, right? We've automated everything. We don't need people to do this job. But don't worry. That's a lot of work. We're not there yet. We won't be there for who knows how long. It's a lot of work. I've been in this in other companies before. It takes forever. And then every time we build something, it's brittle. You know, it works for release 1.1, then release 1.2 comes out. We have to re-record half our script, so we have to go in and make a bunch of modifications to all the stuff we hand wrote. And it's inconsistent. People aren't going to trust what's written in the automation anyway. Eventually, it's just going to go and sit on a shelf somewhere. Usually, I turn to the audience at this point and I say, how many of us have either asked or said any or all of these things? I know I have. I'm raising my hand. Over the course of my career, until I've gotten to the point that I am now, I had a lot of these beliefs. I saw a lot of these things. And unfortunately, this is sort of what many, many people think the automation realm looks like today. But to borrow from our friend Inigo Montoya from The Princess Bride, when we talk about automation, I don't think it means what you think it means. And when I say you, I mean the industry as a whole, what we tend to call automation. But before we get into that, traditions, much like Thanksgiving in America there, can be very important. They can be important, they can have value. And traditional automation does have value. It's really good at detecting behavior changes. It can definitely reduce effort on smoke testing and regression testing, even though I poked a little fun at it a couple of slides ago. It's absolutely something that it can help with when it's applied judiciously. And we can certainly get earlier execution and earlier alerts that way because we don't have to stop what we, the humans, the testers, are doing. We have to stop what we're doing every time a new release comes out or every time something gets pushed to an environment to execute this stuff, or defer execution until some point later because we're in the middle of something we can't stop right now. We can also get scheduled execution with these things. Hey, every time a push goes in, I want to automatically kick this off if you've got some sort of continuous integration or continuous development deployment environment. Or you can say, my stuff takes 20 hours to run. I'm going to kick it off at Friday at 5, and when I come in on Monday morning, I'm going to start going through the results and seeing what sort of problems we may have. All of the previous organizations I've worked with have this. I've either participated in it or it was there when I got there and we've extended it or whatever. We've done this and it is valuable. So I'm not going to call taking, test cases and automating that type of stuff as evil or it's not, I'm not vilifying it here as long, again, as we do it with a good business hat on. But it seems like there's something else. It seems like I see testers spend a lot of their times doing things that could be automated, that some technology could help them with, that while it's not strictly testing in the classic sense, it is preparing for testing, or it is helping organizations be ready to be testable, or anything along those lines. So a few years ago, myself and the teams that I've worked with, and fortunately some of the management teams I've been in, have started to think differently. So what you see a picture of here is something called the Fortis exoskeleton, and it's developed by Lockheed Martin. And the idea is to help humans hold heavy or awkward items for far longer, things that would normally fatigue us much, much quicker. The human here, the guy is holding, I believe that is a grinder, and I don't know very much about grinding, but my understanding it is a tiring job. That thing is sort of heavy and awkward, and when it's spinning, it kind of takes your arms around, so you have to kind of hold it in place yourself. What Lockheed Martin did is they did not say, I'm going to build a grinder robot. They could have, I guess. It's Lockheed Martin. They can build pretty much anything they want, I'd assume. But for whatever reason, they didn't build, or the requesters, in this case, at one of the branches of the military, I think it was the Navy, but I'm not 100% sure anymore. They said, hey, I need something to help with grinding. So what they did is, instead of automating this job, they built something that was valuable, that is going to help the human do the job, because that's where the value was. So when we come to automation and technology and testing, instead of thinking, why don't we automate, or how do we automate, or what do we automate, why don't we think, how do we help the humans? How do we help them be more efficient or more effective at our jobs? Right? We are the rate limiting step. We're the valuable commodity, the time and the effort that we, the human beings, put towards software development. We have to eat. We have to sleep. We have things we like to do. We like to spend time with our families. We like to have hobbies. We can't work tirelessly 24 hours a day, 7 days a week, 365 days a year. It just doesn't scale that way. So we focus on what is valuable. And again, that value tends to be the human being's time. And also, what hurts? What aspect of the job hurts? Because all of us, no matter how much we love our job, there's some aspect of your job that just sucks. And if we can spray some medicine on that pain point, that can make us more effective or more efficient, or sometimes just happier, which sort of tangentially will make us more effective or more efficient. So instead of automation, when it comes to these types of situations, I like to talk about assistance. So this is where we started coining the term, and I say we, myself and a few other people started using this term a little more broadly, and we call it automation assist. And automation assist is really nothing more than an umbrella term for non-traditional automation. I used to work for a guy named Patrick Amaku, and I don't believe this is an original statement of intent, but his quote on this has stuck with me for the last 10 or 12 years or whatever it was, and he first said it. He said, Paul, words mean things. So we have to choose our words carefully. So something like automation in our industry, in our world right now, the software development world, that means something very specific to most people at most times. Right now, I see it changing. I see people like Richard Bradshaw and an earlier Alan Page talking about things that fall under this automation assist umbrella. But right now, when you talk to people, it's what tool do you use? It's how many test cases do you have? It's how many scripts do you have? So instead of fighting that vocabulary change, what myself and some previous leaders that I had, we came up with this new vocabulary for new concepts. And we break this down into three sort of sections of things that increase human effort. One is off-label tool use. So by off-label tool use, if you're familiar with the pharmaceutical industry, roughly to use a medication off-label means to take the medication for something it wasn't originally intended for, but somewhere along the way, it realized it worked well for something else, and it's approved for that as well. It just wasn't the original intent of the medication. For example, there is a condition called macular degeneration where basically you start losing your sight in one or both of your eyes. There are medications for that, but what they discovered is there's a cholesterol medication that will stop or drastically slow down the degeneration. And that would be considered an off-label use of this particular medication. So taking tools that we traditionally would use for traditional automation, test case-based stuff, and bending it to our will, making it do something else to provide value to the organization, that's what we'd consider off-label use. And sometimes there's just nothing out there to do what you need. You need to create something new, something proprietary, because you have a proprietary interface or some sort of proprietary piece of hardware. You'll see this a lot in embedded type of applications, and also other places where it's just not out there. It's just not in open source yet because it is too specific, or because you're on the bleeding edge of what it is you're trying to do. And there's a third section there we're just not going to have time for today. But if you were to see the full-blown presentation of this, we would talk about this as well. But tools not traditionally used in automation. And actually, Alan did a really good job in his keynote doing something that I do very, very close. Actually, he did it live instead of mine, just sort of screenshots. But just talking about command line tools and putting it into scripts and stuff. And then that's really automation, right? That the fact that it's not based on a test case, who cares? You applied some technology judiciously to help some humans do the job. That's what automation's about. So we'll look at a few examples of those first two sub-bullets. One comes from a topic called high-volume automated testing, also called HIVAT. And in general, high-volume automated testing is a family of testing techniques that enables testers to create and run and evaluate the results of arbitrarily many tests. So just huge amounts. And what we're talking about here is we're not talking about performance or load or capacity testing. This is a different kind of thing. The original research that I read on this came from Dr. Kim Kainer, and a lot of it does come either from him or the people he was working with at the time, or people that have subsequently picked up his work and gone on. I also had the opportunity to see Harry Robinson present at one of the STP cons, and he did a great deal of work up front in the high volume automated testing, and he's got some really good, I don't know that I'll call them case studies, but definitely experience reports that he delivered during that session about the value these types of things bring. Well, for the organization I was working with, three of the facets that we were really, really interested in that were bringing a lot to the table for us were obviously the mini executions, random execution, and I'll explain why that was valuable in particular to us and when we get into the example. And number three, the results vetted by the humans. So this is not run this and you get passes and fails and 85% of my scripts are green and the rest are red, and I've got some yellows in there, and Lord knows what that third state means. But humans go in and vet these results. It's really generating a pile of information along the lines of, Here's something a human should look at, because it's not quite the way this program was written and expected to behave. So we invented something that we nicknamed SCUD. So here's the premise. We were doing a data center migration, moving from one data center to the other, but it really was more like an evacuation, because we weren't taking any hardware, any cables, wires, racks, frames, anything. It was bits only. So we're taking just the bits. The product was large, complex, aging, not built to be tested, certainly not built to be automated. And because of the way the data worked, you could actually configure the product based on a per client basis. And we had, I believe it was around 1,200 different client installations we were gonna migrate over a course of many weekends. It just didn't scale to be able to go through and do everything. So we borrowed some techniques from high volume automated testing, and we came up with something that we call the random link clicker, and we nicknamed it SCUD. And the reason we nicknamed it SCUD is, if you're not familiar with the SCUD missile, it was a missile that sort of came into my vision back in the 80s during one of the wars, and it was sort of famous, infamous, but notable because it had a faulty guidance system that periodically would just send the missile off into some random place. So we sort of played on that word for the random access action here. And what it did was it went through and it clicked random menu items on the product, looking for things that didn't seem right. And in this context, didn't seem right. Well, a 400, that doesn't seem right. A 500, that doesn't seem right. 404. In this particular context, the word error on any of the pages probably meant an issue. So that would be something that didn't seem right as well. Anything along those lines, what it would do, take a snapshot, store off the HTML, and as it's going, it's leaving this trail of breadcrumbs of, I went here and clicked this, I went here and clicked this, I went here and clicked this, so that later on, at the end of this run, we would get, hey, we found 4, 5, 8, 10, whatever, weirdnesses, things that were weird, that didn't seem right, that I need a human to go and look at, because based on the things you told me to look for, I found a few of them. We wrote this using Selenium in Python, and it took about 4 days to write. A little longer than I'd originally anticipated, just because of the nature of the way, again, not made to be tested, not made to be automated, this product. So we had to get a little bit creative in how we were going to actually access this menu system. But in just the first week of use, we found 4 issues. Any of those issues could have been something that wound up getting delivered during this migration, and we would have had bugs, would have had, depending on which ones they were, possible outages, possibly where we would have to refund money to our clients. So it very quickly showed its value. So why do we go with this? Value was shown in a previous organization. In another company I worked for, we created a random link clicker. And the random link clicker would do basically the same thing, but because the menuing system wasn't real complicated, we could just do everything based off of URLs. And that showed value very quickly as well, so we thought that approach would be quite appropriate here. Selenium was the right kind of toolkit, and I use that word, or that phrase, toolkit, on purpose. Selenium's not a tool per se, the way you would think UFT or QTP or any of those other ones are. This is a toolkit that you can, or have to, build into something that you can use as a tool. The fact that it was the right kind of tool here, that was just really a library that we could plug in, we could make it do pretty much anything we wanted with it, from the terms of what to click, when to click it, what to report back, and to have complete control. And because Selenium's open source, we had broad license usage, so we could run it in the cloud, we could run it internal network, external network. It didn't matter. We could run it from pretty much any arbitrary location. And we had another tool in-house at the time that we tried to limp along with this. It just wasn't quite the right tool, But by going with something that was open source, we didn't have to compete with the other tool from a license standpoint and decide, do we run traditional automation on 6 machines and Scud on 12 machines, and what's the mix going to be there? Another organization I worked at, we did something with ACH files, and ACH files are automated clearinghouse, I believe is what it's called. And this particular organization, one of their products would generate ACH files. And as part of the traditional automation, they wanted us to check that the ACH files were created correctly. This was a good, really good use of traditional automation, because as part of their workflow, these files would get created, and they were quite tedious and effort intensive to check that all the totals were in there correctly and that all the number of lines and everything were matched up the way they were supposed to. Unfortunately, some funding was cut prior to this project being completed, and while we had some of that parsing and checking done, we didn't have it tied into the general framework for them. And the development was not going to be completed. So what we had was a situation where we had working code that could be adding value to the business, to the organization, but we couldn't do anything with it. So in the time we had left, we decided, hey, you know what? If we just create a command line app that calls into the stuff that's actually finished, we can provide those testers part of their value. It's not everything, and it's not everything the way they intended it, but they were going to save several hours per time they were going to have to validate one of these files. Because even when I was testing this parsing and tool out, it was coming back where I was taking 15 or 20 minutes just by hand, but when I was learning how to do it and then making sure that my calculations were correct, 20 or so or 10 whatever minutes per transaction to do the basic calculations. And that wasn't any of the advanced stuff that the parser was doing, and it wasn't the quantity of transactions that the organization was going to have to do. So we took an afternoon and we created a C# program, and it eliminated hours of testing effort because we ended the engagement with the client because they ran out of cash. I don't have specific effort savings there or effort specific value statement, but based on my own sort of anecdotal data, several hours of testing per file were going to be eliminated, even though we didn't do it all. There were some parts that the clients were still going to have to do. The testers were going to have to check some of the things. A lot of it this did for them. So while that solution, the code was there, was providing no current benefit, we needed to give them some benefit for this. Clearly, it only took an afternoon or so. It was cheap, fast. It was a cheap, fast way to enable value. And like I was talking about, in general, when there's value, something's better than nothing. It wasn't what you wanted. It wasn't everything you needed, but it was a subset of that. Changing tacks a little bit here, the data server regressor. I worked for a company that, oh dear, that's unfortunate. And it's restarting. Bear with us, please. Huh, never had that happen before. Let me find back where we were.
It wouldn't be a testing presentation if you didn't have bugs on the software, right?
I know, right? Well, it's Microsoft too, so say what you will.
Oh, come on.
As I said, say what you will. Every software has bugs. All right, now here's where we are. No, not what we talked about that one. Here's where we are. Let's see if it happens again. Push the van back up the hill. There we go. So the premise here was we're doing, quote, regression testing between software releases. And I have it in quotes because it's not traditionally what we considered regression testing. Traditionally, you'd have a test case and you would run it and you would compare it against previous results and expect it to pass. What was happening here is we were testing against volatile stock market data. We had the capability to replace some of it, but that wouldn't go through exactly the same flow as when the live data would come in. And that's where we'd have our problems, right, is when the live data comes in, something from the stock exchange has changed. So what the testers would do is they would run a previous version of the software, and then next to it, they would run the current version. And at the same time, in both of the servers, the little interface that it had, they would type in a symbol. and it would give them back data. And then they would have to check these 8 or 10 or 12 different things against one another to make sure that, okay, the new server appears to be working the same way as the old one, right? Using the previous software as its oracle. And in order to do this, it took them about 8 hours of effort to go through and run everything, because I think there were 100 symbols they had to go through. And then sometimes we're humans, right? We can't do 2 things at once. A computer's not going to let us do manually 2 things at once. So there was a lot of click, click. Okay, wait, there's a difference between the old one and the new one. Is that because I wasn't fast enough and it was high volume data, or is it because it's an actual issue? So there was some investigation in there as well. This was clearly screaming, write something to do this for us. And we just wrote a comparison tool. It would connect to both servers and compare. It reduced the time to test to just 1 minute. Instead of 8 hours, it would run the same stuff in 1 minute. So they could run it multiple times. We could take releases far more often. We wrote a C++ program, and ROIs in quotes there, but basically we started seeing value to the good after about 6 weeks there. So why this particular solution? Clearly, because the data was hot. I mean, you with automation, either you're going to be able to calculate what you're expecting, or you're going to have to look it up somewhere. There are not a whole lot of other ways to get data, right? So we had to get it from the live system as it was coming in to do the comparison. There was an existing API into the product that was going to let me interrogate the symbols, so there wasn't a whole lot of extra work to do on the product side. And C++ is the primary development language of the organization, so it only made sense to write it in C++. And we found a product bug in just the first execution by the testers. And when I talk about bugs and stuff and problems found here, it's not as a backpat to myself or the teams. It's to show, using these non-traditional methods, we can find things. We can find potential problems, stuff that we may have missed as humans, or stuff that we couldn't automate the regular way just because it wasn't appropriate, or the traditional way, I should say. Also, something called the account creator. This is not actually testing. This is more of clearing effort off, adding value. User account creation was a real pain in the, multiple tables to update if you're doing it via the database, a lot of cross-references, very, very error-prone to do it that way. So it was done via the UI. The UI is slow, lots of typing, a lot of waiting. I mean, we've all used web UIs. It's click, wait, type, oops, made a mistake, start over. Typical stuff there. The solution here was the tester that was doing this. She had some coding expertise, but she knew that writing traditional scripts for this was not going to be worth her while, because the interface was very static. It did not change over time. There was nothing really to maintain. So she created a script using record and playback and Selenium IDE. And I talked to her a little while ago, a couple of weeks ago, and I said, hey, how long did it take you to do that? She said, I don't remember. And it's like a couple of days. Okay, great, cool. So why'd you go with that solution? Well, because it saved 20 minutes per account entry. Every time we had somebody new join the team that needed accounts created in our, quote, pre-production system, so the QA and dev systems and integration, all that other stuff, it was taking about 20 minutes per to do that, between the speed of the UI, human error, and the amount of very specific detail that needed to go in. Also, we had people coming in and out of projects, so we had to create and disable accounts more often than you would think. So it was worth automating this because it was going to happen over and over and over. It was easy to automate via the UI. It was going to be hard and problematic to go via the database. And like I said, she has some coding expertise. It wasn't her forte, but it also wasn't her day job. This was to get past some things she needed to do in order to get to her day job. And then our last example here is something called the zero remover. Typically in the presentation here, this is where I would ask people, how many times do you have to run something before it's worth having automated it? And is it worth automating something you're only going to do once? And usually I get some no's and sometimes some maybes and some yeses. And it really does depend, and that's why I like this particular example. The organization I was working with, they had a tool, and the tool would use thousands of these golden files, so an oracle where you knew what the answer was supposed to be based on the input you give it, and it would run all these calculations, compare them against the golden files, and generate these thousands of result files. And the tool would do the comparison and make sure that everything was all cool with the comparisons. But there was a code change, and in some cases now what's in the database is returning null instead of 0.00. Seems very simple on the surface, just go remove all the 0.00s, but it was a very specific case in which this needed to be done. If you're in this section of the report, and this is the golden file, and there was a lot of brittle stuff in there that's hard for humans to keep track of. The manual effort on this, the estimate was going to be 4 to 6 weeks. After I got back up off the floor and back into my chair, and I said, "You kidding me? How can it take that long?" What I decided to do was sort of spitball, okay, how quickly can we do something if the payback point, the value point was 2 weeks, in case they had drastically, overcomplicated what they thought was going to have to happen here. And it was very easy to do. I mean, you looked at it, it was something computers were very easy at parsing, or were very good at parsing. It was a very easy parsing job for a computer to lay the algorithm out. So just wrote a program to do the file transformation. It took about half a day. And when you say half a day, then you saved at least 2 weeks. In the extreme case, if their estimates were correct, up to 6 weeks of effort you avoided that you were going to have to do because this was a mission critical tool for them. Had to do it, but we avoided that effort because we applied automation and technology in a judicious way. So why do we go with this solution? It's disposable. This is a one and done thing. This got executed exactly 3 times. Well, exactly 2 times other than my debugging stuff. Once for the test architect to go, yep, looks like it's doing the right thing. And then once for the test architect to actually do it for real in the data, and then we just didn't fool with it again. So if you did a normal sort of guess on that, it's like, oh, we're only going to do it once, let's not automate it. You have to look at bigger picture stuff. You have to look at value. You have to look at the scope of what is actually going to be saved or avoided. And we did it in C# because it was an easily distributed executable. I didn't know who was going to run it or when. So I just wanted to build something that they could put out on a file share, and whoever was going to do the work did the work. So some very quick, I know I'm starting to run long here, some very quick words about effort. Effort calculation's a funny thing. It can be hard to do because once you have a new tool, you will use it differently. So you will start getting value differently than just strictly what an effort calculation and sort of savings type of thing is. We like to talk about return on investment. So that level of return on investment can be difficult to calculate because you have these different factors that come in. If you're a strict sort of financial person, ROI may not be the right term to use here. If you read this blog by Dawn Haynes, which I like very much, and if you're not familiar with Dawn Haynes, go look up the work that she does. She's got some good stuff out there. Really, it's cost-benefit analysis that we should be using here, because ROI means something very specific to financial people. And if we talk about ROI, we may not be talking about the same thing they understand ROI is. And a lot of it, I think, is going to start depending on whether or not you're capitalizing something or it's an operational expense. So I'm not going to get any deeper in that there. I'm just kind of saying we should watch our language, because I think opportunity cost is an easier and more useful thing to talk about. And as long as we're thinking about and talking about value, I find that a lot easier kind of vocabulary to use. But if we talk about opportunity cost, financial people will largely understand that. And quickly, some takeaways before questions. This is different. It is not as different as it used to be 5 years ago, which is great. But right now, this is different. You know, if you're, what I tell people, I give a version of this to a grad class here at UT Dallas. And I say, if you take this information and go to your first job interview that you're going to do automation, and you start talking about random link clickers and high volume automated testing, they're either going to look at you like you have 17 heads, or they're going to say, that's cool. Now, do you know Selenium, or do you know QTP, or what is it, right? The traditional automation still rules, and the thought around test cases and scripts and needing specific tool knowledge is still out there. But when you see stuff from Alan and stuff from Richard Bradshaw and stuff from Angie Jones, you can see that it's getting bigger. People are starting to be more rational about how they apply technology. Scripting test cases is okay. Nothing wrong with that, as long as you're approaching it from a business standpoint and understand what value you're doing. But that is an implementation of automation. That is not automation in and of itself. So think about your ecosystem when you're doing these types of things. Who's going to run it? How are you going to get it to them? What's the lifespan? Is it disposable, so you're going to do it quick and dirty? Or is it something that's long-term and you're going to add to and evolve? You want to build it with maintainability in mind. And then when I first wrote this a few years ago, I practiced and practiced and practiced, and eventually I went, you know what, this is the same type of thought process I go through when I'm doing traditional automation versus automation assist. So I don't find there's that much different there from a how you do it standpoint. It's really more about the thought process and looking at the business value and where you apply your limited technology dollars in order to help your testing get better. And that's all I have.
Excellent. So, Paul, first of all, I do want to thank you for the great presentation, and I feel that it comes to complement quite well the stuff that Alan said, and even a little bit about what Chris and Matt were saying yesterday. And if I look into it, I could do a stretch and look at it with the AI and testing that Ayala was talking about before. And the part that I like the most is basically that you're giving us a bigger framework of reference to what a technical tester can actually do. And how can a tester actually do it better? There is a question that I do want to ask you, if you want to refer to it. There's a person here who asked very early in the session if you can give a little bit of insights on RPA with AI. And if you have any experience or thoughts on that.
RPA? Record and playback automation, you mean?
I'm not sure. I think that it was most like robotics.
Robotic process automation and AI.
Yes.
You know, I've only recently just dipped my toe into AI, so I can't really speak with any sort of authority there. But the stuff that Ayal was talking about, very much, it's where my brain is right now, saying, yeah, you know, somewhere down the line we might have robots testing robots and all this other stuff. But right now, the sort of the next steps is being able to take, for example, that tool I was talking about that has all those thousands of golden files and thousands of results. That team had a lot of trouble going through those thousands of results and being able to figure out, okay, it's a failure versus a data problem versus a bug versus, you know, 5 or 6 different categories they would lump these into, and it would take huge amounts of effort. And this is a place where applying something like AI to analytics, you know, the analysis, I should say, of test results, I think could be a big help, where it kind of gives them the idea of, that smells like it might be a problem, and these pile over here, and that doesn't smell like a problem, but you can't ignore it. So start with the ones that smell like a problem.
Okay. I have another question, and this actually comes from background. One of the things that I really like about what you're saying is that, well, I can look outside the box and I can say, what is the biggest problem that I need to solve at this point? And there's a technical answer in order to do it, and let's go ahead and do it. But that's actually pretty quote unquote easy if you have the technical skills, but many testers lack those skills and they still have those ideas. What would you recommend? Let's say that I'm a tester who's not good at C#, he's not good at Selenium or scripting, but I still want to get some help doing some log analytics or analysis or some repetitive functions. How would you recommend me going about my team and saying, hey, go ahead and help me out on that?
Oh, okay. That's not where I thought you were going with that question. I'll go quickly with two things there. One, from the technology aspect of how do I get myself working on that stuff? Go look at that part in Alan's video where he whips out the command line stuff and does that. I do an example very similar to that in the longer version of this talk, and it's a very, very good example of how you can do very simple things with just a little Googling to learn what the parameters for a couple of commands are that can save you a lot of time. And you can reinvest that time into more testing or more learning about automation or whatever the value proposition is there. But when it comes to, hey, I need some help jumpstarting myself from my team, or I need some help with a particular discipline from my team, usually somebody on the team wants to help you. They do. And if you're just on a team where people don't help each other, it's not a healthy team. So you may want to go a little more business route and figure out what opportunities are there. Say, you know what, if we had something that did blah and blah for us, it would save us this amount of effort or avoid these kinds of consequences. And talk to the business type people, like your product owners and your project managers, and say, if we had something like this, whether it's possible or not, let's talk about hypotheticals. If we had something like this, we could save this kind of time. Can we get some cycles to work on this as a team and let the business sort of influence the technology, which to a large extent, that's supposed to happen anyway, right? Because we may be programmers and testers and automation people, but when it boils down to it, we work for a company, and that company needs to make money and be profitable so that we can continue working for that company.
Yeah, I like that answer. So basically go and talk sense to the people who are actually looking for the bugs over there.
Yeah.
Excellent. Yeah. In any case, Paul, I really want to thank you for the question. Guys, remember, if you have additional questions for Paul, you can go over to the Slack channel and continue asking. I'm sure that he can share from his experience and his knowledge and everything. And you can also rate Paul's session in that Slack channel as well. And obviously, we will have this presentation available tomorrow as part of the recording. So, Paul, once again, thank you very, very much for this.
Oh, my pleasure. Thank you for having me. This is fun.
Excellent. Guys, we're going to take a 15-minute break, 18-minute break, according to my watch, and then we're going to be back with Beat Nagaruko, sorry for that, talking about IoT and testing. So take your time. Remember, send us your selfies and comments, and we'll be right back.